Hi, everyone. Welcome to a special kind of bonus lesson that will go over the bonding and molecular geometry. Now, this is actually the second video. If you are in honors or accelerated honors and you did not watch the first video, please go back and watch that one first, where I go through and detail how to go through basically the first 4 or 5 examples on your bonding and molecular geometry homework. This video is created for central atoms that go beyond the four electron domains. So in this video, what I'm going to do is basically skip ahead in the assignment and start looking at some of those later examples in the homework that are just for honors and accelerated honors students. Okay, so we're going to go ahead and start with problem number 5. So the nice part about problem number 5 is that the Lewis structures were already drawn for you, so that part is nice. The other thing that I want to mention is what I'm going to do is go ahead and identify the difference between electron domains and bonding domains on these examples. So if you're confused by that, which I know some of you were, we'll be able to answer that as well. All right, so the first thing that I would like to do is to start off by looking at the number of valence electrons. So for chlorine's in group 17, so it has 7 valence electrons. There are 5 chlorines, so 7 times 5, that's 35 valence electrons, plus the 5 from phosphorus, that's in group 15. So 5 valence electrons plus 35, we have a total of 40 valence electrons here. This is what your Lewis structure would look like. Like I said, the nice part about this is already done for us. But what I wanted to do was go ahead and add in just a little circle to kind of identify where our bonding domains and our electron domains, we'll start with electron domains, obviously. We're going to start with those and then just identify each of those for you. So in this problem, we have 5 electron domains. So I'm going to just rotate these as I use them so that we can identify where they're at. So here's one. Here is another one right here. Next one is kind of over here. Let's rotate that a little more. We have one pointing straight up. So as you can see, we're going to wind up with 5 electron domains here, all 5 of which are bonding domains. So 5 electron domains, all 5 of them are bonding domains. So in these 2 boxes, we're going to put 5 and 5. The next thing is the VSEPR theory guide. This is going to be crucial. So please go back and make sure that you have the right answers for this. So what we're going to do is we're going to scroll through these examples until we come up with a combination of 5 and 5. So here we are, 5 and 5. Notice that the name is the same in both cases. So I can copy and paste this, trigonal bipyramidal. I'm going to paste that into both of these spots. And then I'm going to make my drawing look like the drawing in the VSEPR theory guide. So I'm going to have one to the left, one straight up, one straight down, then kind of one toward the back and one toward the front. And then I'll show you what to do with those arrows as well, because that was also a kind of a spot where students were kind of confused. All right, so I'm going to start rearranging my atoms here. So I have a chlorine straight up, a chlorine straight down, a chlorine off to the left. So I'm going to put that one in first. And then a chlorine that's supposed to be back behind the plane, and a chlorine coming out of the plane. These are already in the right positions, so you don't have to really do anything with those. So we're going to have one straight up, one straight down, and one to the left here. The last part are these arrows. Now, my first suggestion to you with the arrows is to make these boxes smaller. I'm not quite sure why they ended up so large, but they're kind of difficult to maneuver when they're that large. So if you just shrink the boxes, it makes rotating them just a heck of a lot easier as you're doing this. Okay, so now, because chlorine is more electronegative than phosphorus, it's closer to the top right. Because chlorine is more top right, I guess for you guys is over here. Because chlorine is more electronegative than phosphorus, we're going to have all of our arrows point out toward our chlorines. So all 5 of them are going to point out. I know in the examples that we did on the video, one of the earlier videos, the arrows were pointing in, and that was because it just so happened that the 2 examples that we had more electronegative atoms in the center, but in most cases, the arrows will end up pointing outward. It's just when you have hydrogen, you can't put hydrogen in the center, so the arrows are always going to point away from hydrogens. Okay, so we have, oops, I meant to make that 90. It's a little difficult to do, even for me sometimes. So I understand if you're getting frustrated by these because they can be quite frustrating, especially to try and move. All right, so there's another one. The one over here, we're gonna have point straight toward the left. So we're gonna flip that so that it's 180, perfect. And then one more pointing up toward the top. So we'll call that one 270. There we go. And then trying to get that 4-headed arrow, which allows us to move it, that can also be tricky. There we go. And we're going to move this one right up here. Now, I like to move everything over to the top left because I think it looks smaller when we bring it back to this screen. All right, a couple of reminders here. So the bond angle you can also copy from here. So this one has a whole bunch of bond angles. So we could just go ahead and copy paste them into the bond angle part here. These are all sigma bonds in this molecule. There are no double bonds. You would know that because in the molecular geometry picture, you would see that thing that looks like an equal sign. You've seen that in some of the earlier videos. So we have 5 sigma bonds, no pi bonds. Remember that our bond polarity is going to be polar pretty much in all cases. This is the part that I want to make sure that everyone is aware of. I created in this bonus lesson 2 quick slides here. So the first one is going to help us figure out molecule polarity. So a 5-5, where all 5 attached atoms are the same, we're going to call that one nonpolar. So in this case, we're going to write nonpolar down here. And then finally, in the intermolecular forces of attraction, the next slide is another kind of cheat sheet. If the molecule is nonpolar, then we have LDF only. So in this box over here, we're going to write LDF only. You don't even need to write the only part. But that was our 5th problem. So if you have any questions, please either rewatch this part or send me a message and I'll try and answer those for you. Let's take a look at problem number 6. We have XeF2. So it's not usual to see a noble gas in a bond, but it does happen occasionally. So fluorine has 7 valence electrons. There are 2 of them, so that's 14. And then we're going to add 8 more because of the xenon. So 14 plus 8 ends up being 22 electrons total. Let's go ahead and take a look at the electron domains and bonding domains. So we're going to add on these little circles here. Again, you don't have to do this. I'm just doing this so that you can take a look at them in case you had any questions identifying them. So I'm going to get a whole bunch of these here. So we're going to put 2 along these spots here. That's 2 electron domains. There's another electron domain here. Anytime you have an unbonded pair of electrons, they actually count as their own electron domain. So there are 3 electron domains around the central atom here that are not bonded. 5 electron domains total. I'm going to make the ones that are bonded blue so you can see the difference here. So we have 5 electron domains in total. The 2 that are bonded are the 2 that I turned blue, and then the other 3 are non-bonded. So in this spot, we're going to write 5 electron domains, only 2 of which are bonding. So now we jump over to our Vesper theory guide. We have 5 and 5, 5 and 4, 5 and 3, bam, 5 and 2. So the 2 names that we're looking for, trigonal bipyramidal, we're going to copy and paste that one onto the top. That's the name that we have up here. And then for the second part, because we only have 2 of them bonded, we wind up with a shape that we're going to call linear because they're all in a line. And then we're going to make our drawing look kind of like it did on the previous slide. So we're going to put xenon in the center, and then we're going to put our, I don't know what that was, so let's just delete that. We're going to put xenon in the center, and then we're going to put our 2 fluorines. We're going to put one fluorine straight up. We're going to put the other fluorine straight down. And then we're going to connect all of our lines into their proper spots. And if you're doing this and you forget exactly what it's supposed to look like, just go back and look at this Vesper theory guide, because that is an excellent way to make sure that you're doing this correct. And on all three of these are called the equatorial positions. On all three of these equatorial positions, we're going to have pairs of electrons. So I'm going to just move these electrons into groups of 2 that are in these 3 positions here. So we're going to do that here, here, and here. Perfect. And the last thing that we do, we're going to move our arrows into position. Of course, they're going to point toward the more electronegative fluorines. So one's going to point straight up. So I'm just going to grab this and rotate it so that it's straight up. The other one's going to point straight down. So I'm going to grab this one and rotate it down like that. If we can get those 4 arrows to show up just like this. Now we can move these 2 into position. So we have one there, and we have our second one up here. Okay, so at this point, this is what our structure looks like. I'm just going to shrink this down a little bit. There we go. In terms of the bond angles, I'm encouraging you to copy and paste them from right here. So it's a single bond angle. So the fluorine, xenon fluorine is a 180-degree bond angle. There are 2 sigma bonds. There are no double bonds in this. So for the bond polarity, we're going to write polar. For the molecule polarity, we're going to go back and look at our cheat sheet here. So a 5 and 2 is right here. Since they're both fluorines on the end, we can call that nonpolar. And then similar to what we saw for carbon dioxide, we're going to again look at our sheet here. For nonpolar, we have LDF only. So LDF in this spot here, and we are now done with problem number 6. Again, if you have any questions, please let me know. Okay, we're going to move on and take a look at problem number 7. So problem number 7, we have 3 fluorines, that's 7 each, 21 plus a chlorine, 7 more. So a total of 28 valence electrons. We're going to identify the number of electron domains and bonding domains using these little circles that I'm making. So we're going to, I'm just going to make them, we're going to have 5 altogether on this example. So I'm going to make the ones that are bonding blue, as soon as I do that in a second. So here is, first we'll identify all of them. So I'm going to do this and I'm going to rotate these just like that. So I have 2 there. I have 1 pointing straight down. So it's going to be a 90-degree one. Again, you don't have to do this part that I'm doing. I'm just doing it so you can identify where all of the electron domains are. So that's going to go around these 2 right here. And then finally, the last 2 are right there. So now, out of the 5 electron domains that we have there, 3 of them are bonding domains. These 3 that I'm turning into blue, those are the 3 bonding domains. So I'm going to move this up to the top here. And there we have our 5 electron domains, 3 of which are bonding domains. So 5 here, 3 here. I'm going to jump over to our Vesper theory guide, slide up 1. Here's our 5-3 combination. So the name of the electron domain geometry is trigonal bipyramidal. That's going to go in the top box here, just so you could see that. And then in the lower box where it says molecular geometry name, we have this T-shaped planar right there. So we're going to pop that in there. And then finally for the bond angles, we're again going to grab these right from here and we'll just paste them in right there. Now, we're going to make our drawing look just like the drawing here. So we're going to have a fluorine up, a fluorine down, and then a fluorine in the back on this gray wedge here. The one to the left and the one to the lower right, those will both be pairs of electrons. So let's figure this. We're going to put chlorine in the center. And it always does that, always grabs something other than what you want to grab. All right, so we're going to put a fluorine up at the top, and then we are going to put a fluorine back here. And that's going to be the one that's attached with a gray wedge. Then a line straight up, a line straight down. Oops, let's try and line those up so they look a little better. And then finally, we're going to have a line to the left. And on that line, we're going to put not 3, but 2 electrons. So we're going to put 1 here, 1 there. Oops, I like trying to line them up, but sometimes you can't. And then down here on the lower right, we're going to put another pair of electrons. And then as far as our arrows are concerned, so after I shrink these boxes, as far as our arrows are concerned, what we're going to do there is they're going to point toward the more electronegative fluorine in each case. So in this case, what I would like to do is I'm going to rotate one of them so it's straight up. I'm going to put one pointing straight down. And then I'm going to have one pointing back toward the back right there. So let's see if I can get this to be 4 arrows here. I can move this. There we go. So we're going to move that one right over here. And then this one we're going to move so that it is pointing down. Alrighty, and then see how that looked all the way to the right there? The way to fix that is to just grab everything and move it over here to the left. Then once that happens, you could just make it smaller. Okay, so in this case, no double bonds. We have 3 sigma bonds. We have no pi bonds. The bond polarity, as we said, is always going to be polar. Now, in this case, when we have a 5-3, we have a molecule that is always going to be polar. So we're going to put in polar here, and then we're going to put in our, in terms of our intermolecular forces rather, we have polar, we don't have any hydrogen bonding, so we have LDF and dipole-dipole. Okay, so that completes our 7th example. Okay, let's go ahead and take a look at problem number 8. So in problem number 8, first thing that I want to do is count up the total number of valence electrons. So I have 7 from fluorine, I have 6 fluorines, so that's 42, 7 times 6. And then I have 6 more from the sulfur, so that's a total of 48 electrons there. Now I'm going to go ahead and add in our electron domain circles. You don't have to do this. I know I said it 50 times, but I just don't want to get any emails that say, do we have to do that? So these are going to indicate for us, in this case, by the way, all of them are going to be bonding. So I'm just going to make them blue to start off with. And let's get them into our positions. So we're going to have one straight up here. So that's our first one. We're going to have one that's straight down. So I'll make that one. There we go. And then we're going to have one that's kind of down and to the left, one that's down and to the right. One down and to the left here. One that's down and to the right. And then we have 2 more. So we have 2 that are up here. And 2 that are over here. So we have 6 total, all 6 of which are bonding. So in this case, if we go to our Vesper theory guide and we find 6 and 6, that is the name octahedral, and it's both the electron domain geometry name and the molecular geometry name. So we're going to paste that in both spots. And then there is a ton of bond angles here. So we have 12 copies of that 90-degree bond angle. And then, of course, our 3 180s. So I'm just going to drop those bond angles in there as well. So for electron domains and bonding domains, we have 6 of each. And again, I'm going to try and make this picture look as much like this picture as possible. So we're going to put our sulfur atom in the center. Then I'm going to use these lines to kind of guide the rest of them. So we're going to have something straight up. We're going to have something straight down. These wedges that are filled in black, those are meant to represent bonds that are coming out toward you, so out of the computer. And these that are colored gray are meant to represent the bonds that are back behind the plane of the screen. So imagine them as in back of the screen. And then I'm going to finally move my fluorines into these 6 positions here. So we're going to put one on top, one on the bottom, and we have one coming out at you toward the left, one coming out at you toward the right, one back behind the plane on the left, and one back behind the plane on the right. Now, of course, we have a ton of these arrows here. One of the things I'm going to do is I'm just going to get rid of all of these really quick, and let's see if it'll let me select them all. I'm going to make the box smaller to begin with. That way I don't have to do that part 6 different times. And then I'll just paste those. There we go. Okay, so what we're going to do now is I'm going to hopefully move some of these arrows into their positions. So we're going to have one pointing straight up. We are going to have one pointing straight down. See if I can move this guy. We're going to have one pointing toward the back. We're going to have another one pointing toward the back, but this time toward the left side. Let's see if I can grab that. Oops, grabbed a different one. All right. This one is going to point down here to the lower left. This one is going to point toward the upper left, and this one's going to point down towards the right here. Okay. Again, the reason why I'm showing you this, it is just making you feel better about some of the frustration you might be experiencing moving it. I am also, of course, getting frustrated with trying to move those. They are difficult. And you can do this on paper if you would prefer to print it out and do it there. Okay, there are 6 sigma bonds and 0 pi bonds. The bond polarity for each of these is going to be polar. The molecule polarity, we have a 6-6 combination. So 6 and 6 right here, octahedral. That's a non-polar molecule as long as everything attached is the same, which it is in this case. So this is going to be non-polar, and then because of non-polar, the only option here is going to be LDF, and I'll show you that on the next slide. So if the molecule is non-polar, again, it's LDF only. Okay, so that completes number 8. We are getting there. Number 9. Okay, let's take a look at number 9. We have 7 fluorines, that's 7 times 5, 35, plus a bromine, 7 more, so that's a total of 42 electrons here. I'm going to go ahead and help you identify bonding and all electron domains, and then of course bonding domains. So I'm going to make this transparent, make it red to start off with, and make it just slightly larger. And I'm going to have 6 domains in this case. So we're going to make this one. This one's going to be our domain on top, electron domain on top. This one is going to be our electron domain on the upper right here. So that's 2. Lower right, that's 3. The next one is our one on the upper left here. That's 4. I'm going to need another one. So this is on the lower right, or excuse me, lower left. That's 5. All of those are bonding ones, and then we have one non-bonding one. So I'm going to change all the ones that are bonding just so you can kind of differentiate them to this blue color. And then the one that is the non-bonding one, I'll leave in the red color. Perfect. So I have 5, 6 all together, 5 of which are bonding. So I'm going to go 6 here, 5 there. Now go to your Vesper theory chart. Here's 6, 6. Here's 6, 5. Just scroll down 1. So we have octahedral. That's the electron domain geometry because there are 6 altogether. And then the molecular geometry, because only 5 of them are bonded, is called square pyramidal. So it looks like a pyramid with a square base. So, and the electron pair is pointing down. So I'm going to try and make that using my atoms here. And again, if you're ever doing this part and you want to look back just to make sure it looks similar, so we're going to have fluorine up at the top. We're going to have our pair of electrons go toward the bottom, just like it is in our example. I'm going to just move this here. Let's get this guy a little closer. All right, and then the pair of electrons I'm going to put down here. And then after that, we're going to put fluorines on the ends of all of these. So the ones, again, that are black are meant to represent the ones that are coming out toward you. The ones that are gray are meant to represent the ones that are back behind the plane of the paper or screen. And let's see. Then the last thing, again, I'm going to do is move all of these arrows into position. So I'm going to rotate this arrow. We're going to have them, they only go along the bonds. And in this case, they're going to point out towards all of our fluorines. They're actually easier to rotate when the size is large for some reason, which doesn't make any sense to me, but it's easier to get that four arrows rather to show up when it's smaller. So these are going to point out toward all of my fluorines. And the last two, I'm going to point this one down here. And finally, this one up here. Alrighty, so we're going to grab that, move that all over. Perfect. Okay, I'm going to grab the bond angles again from my Vesper theory guide here. We have a 180-degree bond angle, two of them. That's this one here and this one here. And then we have the 90-degree bond angles, which is, which actually should be 8. So there are 90-degree bond angles with each of these, and then with the top. So the bond angles here, we're going to paste. Oops, and I didn't do the change because I did that afterward. All right, so we have sigma bonds, 5 of them, no pi bonds. The bond polarity itself, we're going to say is polar. This molecule, anytime we have a 6-5, which is what we have here, square pyramidal, that's going to be polar all of the time. So this is polar. And there's no hydrogen bonding, so this is going to be LDF and dipole-dipole. Okay, couple more. Hang in there. So we have number 10. We have number 11. Those are going to be the last two that I go over. Number 12 I actually did in the earlier video. I think it was called number 5 there. So if you're looking for where to find that answer, it's in an earlier video. So let's take a look here. We have 7 times 4, that's 28, plus 6 more, that's 34 electrons total. In terms of electron domains, we're going to have 5 electron domains here. So I'm going to make this blue to start off with. So we have 1 bonding domain here. We have 1 bonding domain here. We have another bonding domain here. We have 1 more pointed down. We have 1 more pointed down. And then what we're going to do is I'm going to color this last one red. This one is a non-bonding domain. And we are going to put that one right on those 2 electrons that are really close to each other right there. Okay, so we have 5 electron domains total, 4 of which are bonding. So a 5, 4, go to our Vesper theory guide, scroll up till we hit 5, 4, here we are. So the name of the electron domain geometry is trigonal, bipyramidal. So control copy that. Paste that right up there. And then this is our seesaw example. So we can put that in right there. Okay, and then finally, while I'm on that, I'm just going to grab all these different bond angles here. The 180, the 120, and the 90. And if you're wondering where those are coming from, go back and look at the VSEPR video, the Vesper Theory Guide video, where I went through all of that information. Okay. In this one, we have 4 sigma bonds. We have no pi bonds. we're going to make our picture look as close as possible to this. So we're going to have one straight up, one straight down, one coming out, one going back, and then straight to the left is where we'll have our pair of electrons. So I'm going to move that early on, just get that out of the way there. Here's our pair of electrons. Here's our bond pointing toward the back. Here's our bond pointing toward the front. Here is our straight up. Here is our straight down. And let's move all of these fluorines into position. So we have fluorine here. We have fluorine up, fluorine down. This fluorine is going to be the one in the back. This fluorine is going to be the one in the front. And then fluorine is obviously the most electronegative element. So all of these arrows rather are going to point toward our fluorines. Let me move these into position. Oops, let's put that a little bit lower. There we go. This one's going to point down. And then these two will point outward toward the fluorines that are here. So one fluorine there. And this one's going to go right here. Oops, there we go. Nice, very nice. Okay, so I'm going to move this all over to here. The way it looks nice in our picture, which disappeared. Oh, it's too big. All right, so we're going to make that a little bit lower. There we go. So it's filling in the last parts here. So for the bond polarity, that's going to be polar. For the molecule polarity, go look at the 5-4 combination. 5-4, always going to be polar. So in this box, we can write polar. There's no hydrogen bonding here. So since we have polar with no hydrogen bonding, we have LDF and dipole-dipole. And if you're questioning what any of that means, go and watch the video on intermolecular forces of attraction, and I'll describe why some are called LDF and why some are called dipole-dipole. Okay. Now, we are on the last example that we are going to do together. So we have xenon tetrafluoride. And in our next unit, we'll actually learn how to name these compounds. So that'll make more sense in about 2 weeks. So the number of valence electrons that we have, 7 times 4, 28 for fluorine, plus 8 more. So that's a total of 36 electrons. Now, again, this part you don't have to do, but I am going to do it just to help you identify the number of electron domains and bonding domains. So some of you are probably saying, why does he keep saying it? Okay, we're going to, so we have 2 electron domains that are non-bonding. So I'm going to move those into position first. And then, so those happen to be these 2 right here and these 2 right here. Remember that we're always placing electrons in pairs, so you're never going to see just an odd electron somewhere by itself. So we're always placing them in pairs. The last thing, so now I'm going to create another mark here, this time for the bonding electron domain. So I want this to be blue. I'll make this a little smaller. And we have 4 copies of that, so 1 here, 1 there, 1 that's pointing straight down, that goes right there, and then 1 that's pointing straight up. Perfect. Okay, so we have six electron domains total, 4 of which are bonding domains. So we have 6, 4. Now we jump over to the Vesper theory guide. Let's find where that is. 6, 6, 6, 5, 6, 4. So we have our electron domain geometry name. That is octahedral. So I'm going to copy and paste that into here. Then we have our molecular geometry name. That's square planar. So I'm going to paste that into there. And I'm going to go and grab those bond angles, the 180 and the 90. I'm going to paste that into there. This one has 4 sigma bonds, no pi bonds. Now we're going to make our picture look like our Vesper theory guide picture. So there's going to be 2 in the back, 2 in the front, and then one straight up and one straight down. The one straight up and straight down are the pairs of electrons. So we're going to have a line going straight up to a pair of electrons, and then a line going straight down to a pair of electrons. Let's see if I can grab them in twos here. Put those two there. These two down here. Again, the ones that are black like this are meant to represent bonds that are, this is a three-dimensional structure, so they're representing bonds that are coming out of the plane of the paper. The gray ones are representing ones that go back behind the plane of the paper or the screen. Gotta get with it. And then the last four fluorines are going to be here. And all of these arrows are going to point out toward the more electronegative fluorines. So I'm just going to rotate these into position really quick. Hope I did that right. There we go. Out toward the fluorine, out toward the fluorine. This one's going to point kind of down and to the right. And again, for reasons that I can't explain, getting that 4 arrow to show up when it's super big like this actually works better. Doesn't make any sense to me, but it does. Okay, so let's undo what I just did there. Perfect. And let's move this over to here. So finishing this up, our bond polarity is going to be polar. Our molecule polarity, so let's take a look at our cheat sheet here. So we have a 6-4 where all of the things attached are the same. So that's going to end up being nonpolar. And then for something that's nonpolar, remember that LDF is the only possibility. So for nonpolar, LDF only. Again, I will make this available to you so that everyone has that. And that's it. This last example, as I mentioned already, it's not done here, but it is done on an earlier video. And I'll post the answer keys to all of this so that you can see it all. All right, thanks everyone. Have a great day, and thank you for staying to the end of this video.